the form of a chemical equation is usually some chemical A plus some chemical B gives you some chemical C plus some other chemical D. Okay, so there could be any number of chemicals on either side of the arrow, and it doesn't really matter which one. Okay, so it could be 20 chemicals form 2, or 40 chemicals form into 1, or 1 chemical turns into 60 other chemicals. The number is not set. You can have as many as you want. So A and B are reactants, and C and D are products. So in order to obey the law of conservation of mass, so for instance, mass just can't disappear. That doesn't happen. So that's what the law of conservation of mass is, that mass must be constant on both sides. And so we need to balance equations to do this, okay? So we need to balance this equation somehow so that we have equal numbers of atoms on either side, okay? So balancing equations quickly comes with practice, and I can't stress this enough. The more practice you get at it, the faster you'll be. When I was making this particular lesson, I struggled to develop a foolproof way of doing it because I've done it for so long. I have my own systems and I skip a lot of steps and things. So I struggled to make this actual lesson for you because I have a lot of practice doing this. And that's the only way you get good at these things, by practice, okay? Now, another thing is that there's no right way to do this. You can do it however you want, but there are less efficient ways of doing it. I'm going to teach you in this lesson a foolproof way of doing it, so there's no way you can miss out if you do it this way, but it is less efficient than other methods, okay? So I could solve these questions much faster if I did it my way, but you may not be able to follow it if you've never seen this before. So I'm going to give you the full version of the solution, and as you get more confident and as you develop your own techniques, you can start to chop and change a little bit, and you'll be able to speed up the process by like an order of magnitude or something. There are no right ways, but you can have less efficient ways, or ways that will give you the wrong answer sometimes, okay? So to actually complete these chemical, or to explain these balancing steps, it's probably easier that I just show you a question and work through it with you, rather than actually trying to explain each step in an abstract way. So this is the best way to look at balancing these chemical equations. So we've got this fuel, ethane, and it reacts with oxygen to give you CO2 and H2O. So we want to write a balanced equation for this. So from the question, we know that the reactants are C2H6 and O2, and the products are CO2 and H2O. So if we were to put it into a general equation, we'd have this A times the fuel plus B times the oxygen molecules gives you C times CO2 molecules and D times H2O. Okay. So what these numbers A, B, C, and D mean are just how many of these molecules do we need. If I needed 1 H2O molecule and 6 CO2, then C would be 6 and D would be 1. We're looking to find A, B, C, and D. That's the goal of this whole process. So these numbers A, B, C, and D multiply by the number of elements in a molecule. For instance, if B is 6, then the number of oxygen atoms on the reactant side is 6 times 2, 6 times 2, which gives you 12, okay? So if you've got 6 O2 molecules, then you've got, and 2 oxygen atoms per O2 molecule, then you've just got 6 times 2 oxygen atoms, which means you've got 12, okay? So in the general case, this one, the number of C atoms on the reactant side is 2 times A, which is the same as 2A. So this is just algebra, okay? Just very, very basic algebra. That's all we have to deal with here. So now what are the steps? So the step 1 is take either elemental metals or the most complex molecule and set its coefficient to 1. Okay, so what that means is look for single element metals. So if I saw like a Cu here, okay, if that was our actual equation, then, and there'd be like an E here, then E would be 1. That's what the first step means. Just take any elemental metal, just the first elemental metal that you can find, and set its coefficient, E, to 1. Now, obviously this one doesn't have any metals in it. You can't see any metals. You can see a fuel, oxygen, CO2, H2O, then none of those are metals. So what you do is you set the most complex molecule, set the coefficient of that molecule to 1. So if there's no elemental metals, then look for the most complex molecule. So if you look at this, which one do you think is the most complex? Well, I think this one is. So I put A equals 1. Okay? Now, the choice here is arbitrary. Whatever you do, it doesn't matter. I could set C to be 1, D to be 1, B to be 1. Doesn't matter. The only difference is that it may give you more work later on. So that's why I decided to show you this method. Okay? So here's our equation. And it's because A equals 1. So this equation goes to this one. You can see A has become 1. So we just ignore it. We don't leave it there. Just like you don't write in algebra 1y, we just write y, okay? So that's the first step. That's probably the hardest one to understand, but just work with it for now. The explanation for this, why we do this, it comes at university level maths. So when you go to university, study engineering or science, you'll learn why this happens. But right now, you don't need to worry about it. So like I said, you can turn any of them to 1, but the most complex molecule or the elemental metal is usually the best choice. So now this next step is sort of a half step. You don't have to do this. You don't have to write this down, but this will help you a lot. So figure out which elements appear in only one molecule on the product side and one on the reactant side. So what that means is, if you look at this, oxygen appears once on the left-hand side. So it appears only in this one. But oxygen appears in this molecule and this molecule on the right-hand side. Okay? So you can see that happens, right? But what we want is we only want it to appear once. Okay? So we're looking for elements that only appear once on either side. So you can see carbon appears in this molecule and carbon appears in this molecule. So that's good. That's something that we want to take note of. Hydrogen appears in this molecule and this molecule, but it only appears once on either side. So that's good again. We need to note that because it'll make our balancing a lot faster. So the elements that appear only on one side, once on each side, we balance first, okay? And in time, you'll start to figure out why, but I won't explain it now. I'll let you sort of work through it and get there. But you'll start to see why that happens later on. So looking at the equation, we see carbon appears only once on the reactant side in the ethane molecule and once on the right-hand side in the carbon dioxide molecule. The same applies for hydrogen, and oxygen can't be balanced first as it appears in 2 molecules on the product side, so here and here. Okay? Now, step 3, there should be equal numbers of elements on reactant and product sides, so we create equations that represent this and solve them, okay? So if we balance for carbon first, there are 2 carbons on the left-hand side, right? Because remember, A is 1. We always set A to 1. So C equals, so there's 2 on the left-hand side. But on the right-hand side, we have C times 1. So we need to make sure that C times 1 is the same as 2. Okay? So what we say is 2 on the left-hand side equals C times 1. So C has to equal 2. Simple algebra there. We balance hydrogen next. There are 6 H's on the right-hand side, because remember A is 1. So 1 times 6 is 6. And there are 2 times D H atoms on the right-hand side. So there are 2 times D of these H's on this side. There are 6 on this side. So we write that down as 6 must equal 2D. Now if we rearrange that, D equals 3. Fairly self-explanatory. And oxygen. There are 2 times B oxygen atoms on the left-hand side and 2 times C oxygen atoms on the right plus D. Okay, so 2 times C, that's that many oxygen molecules here, oxygen atoms here. And there's also D oxygen atoms here. So there are, in total, 2C plus D on the right-hand side. Now, substituting from the previous equations, we know that D equals 3 and C equals 2. 2B equals 2 times 2 plus 3, which equals 7. So B equals 7 on 2. Okay? Then we just replace the pronumerals with the numbers that we calculated from just before. Okay, so A equals 1, B equals 7 on 2, c equals 2, and d equals 3. And that's our final equation. And that's how we balance equations. Those are the 3 or 4 steps that we need, and that's how we get it. So like I said, as you get better and better with this, you won't need to go through each step. You'll be able to skip steps. But right now, this is what you should do just to get a feel for it. Now, if you're worried about that 7 on 2, you don't need to worry. You can have it as a fraction. Some teachers don't like it, so make sure you consult with your teacher what they prefer. But for me, I don't mind having them because these numbers don't mean how many molecules. They actually mean something else. They mean how many moles. And so you don't need to worry about having fractions, okay? But, talk to your teacher about it. I know lots of teachers don't like it. So if you're uncomfortable with fractional coefficients, just multiply everything by the denominator. So if I wanted to get rid of that fraction, I'd multiply this by 2, this by 2, this by 2, and this by 2, and that solves our problem, okay? So example 2 now. Balance this equation. SnO2 plus H2 gives you Sn plus H2O, okay? So first we put it in general form. So we just write A, B, C, and D in front of each of the chemicals. Very simple first step. So this is sort of the most complex compound. So we set A to be 1. Now alternatively we could set this one to be 1 because it's the pure metal. But the result is the same. Let's just set this one to be 1 just because it's on the left hand side and we'll work left to right. So this is 1, or A is 1. So we balance the Sn metal first, so the tin metal. So if we have A numbers of Sn on this side, and we have C numbers of Sn on this side, we need to know that A equals C, right? So therefore C also equals 1, because we know A equals 1. We balance oxygen next. There are 2 oxygens on the left hand side. There's one on the right, well there's D on the right hand side. So 2A on the left hand side. There's D on the right hand side. So to make sure that they balance, we need to say that 2A has to equal D. And we know that A is 1, so D must be 2. We balance for hydrogen. There are 2B on the left hand side, and there are 2D on the right hand side. So we know that B equals D, if we just cancel the 2's. So B equals 2. So B equals 2 as well. Then we just substitute back into the original equation. A equals 1, as you can see. B equals 2, you can see that. C equals 1, and D equals 2. Okay? And that is how we balance equations. So that's the end of this lesson on balancing equations. We've looked at how to balance the equations, what are the steps. And as I said, this is a key point. If you take anything away from today, this is what it is. There's no right way to do this. So once you start to get comfortable doing this, then you can start to manipulate the steps as much as you want, as long as you get the right answer. Because this is not the fastest way, but it's the way that never fails. So I've given you the tool that always works, and it's up to you to now use that tool and modify it so that you can work faster and do the questions in your own way. Okay? So that's all I'm trying to teach you today.